This poster describes the findings of a very collaborative project that was funded by a small grant from the BA Leverhulme Trust, and I very much appreciate their support for making it happen. It's actually quite a complicated poster, and unfortunately I don't have time to go through the 3 detailed experiments here, but I'll give you a very brief overview in the hopes that it encourages you to come and find me at the EPS meeting in Stirling in July. For those unfamiliar with bubbles, it's an experimental technique, similar to reverse correlation, that is capable of revealing the diagnostic visual information for a given judgment. It's a really cool and powerful technique, but has some downsides, not least being that sessions are challenging and exhausting, comprising typically many hundreds of trials, which has traditionally kept participant numbers low and experiments confined to laboratory settings. Recently, there's been an increased interest in using this approach to study questions associated with individual differences and in work with more diverse participant groups that benefit from being tested outside the laboratory. With this in mind, the current project evaluates whether we might be able to make a couple of small but critical modifications to the standard paradigm in order to reduce the number of trials needed to reliably yield meaningful individual level results. For example, we proposed switching from random to non-random sampling of the stimulus space. While random sampling of locations on each trial is entirely unbiased and obviously great in that respect, it also sort of necessarily leads to redundancy and large trial numbers to ensure that every location is sampled and captured a sufficient number of times. We also elected to present each participant with the same stimulus images in the same order, which permits an exact comparison across participants because we're sure that they saw and responded to identical information. In the poster, I detail 3 experiments that chart the development of this work. Study 1 details some simulation modelling that we did to determine the number of trials that were necessary to reliably establish a stable classification image with our modifications. Study 2 details a long-form bubbles experiment that we ran with a small group of highly motivated participants to validate the computer-based modelling results and confirm the necessary number of trials for a stable individual-level solution. Study 3 details a short-form bubbles experiment that we ran with a large group of participants online. Each participant completed 1 or 2 sessions of our streamlined task, along with 2 measures of face expertise. This study allowed us to evaluate not only the extent to which our modified task is methodologically sound, but is also sensitive to functional correlates of information use, in this case, face recognition memory and discrimination ability. If you want to know more, my 3 minutes are up, so you'll have to come and check the poster to find out what we saw.